All right, welcome. Here we go. Let's get this started. We are going to talk about the composite figures and shaded figures areas. Today, you're going to develop strategies to find areas of composite figures and shaded figures. So, my goal here is I know you have another video where you can do this, but to help you get an idea of what you can do, give you some new ideas on how to develop or strategize ways to develop this. All right, so first off, let's start with a composite figure. A composite figure is a figure that can be separated into regions that are the basic plane figures, like triangles, parallelograms, trapezoids, rectangles, circles, etc. To find the areas of these composite figures, divide up these regions. So divide up the regions. In other words, break them up and find each area, and then you can add up those areas. Okay, for example, if you look at this first one, and let's say, I've always wondered how I wanted to decide this, but okay, like, look, this right here is a rectangle. So but let's divide up these regions. Let's number these regions. Let's say this is region 1, region 2. Okay? Region 1, I'm going to put here. Region 2, I'm going to put here. Okay, so what you should be able to see is in region 1, that's a rectangle. Okay? So that rectangle right there, you just need to say base times height. So there you would say 12 times 23, add or multiply those, and you should get 276. Okay? Now, the next one is region 2. Region 2 is a trapezoid. You need a B1, a B2, and a height. So, before I even try to figure this out, well, let's see here. This whole thing is 18. That's from here to here. But from here to here is 12. So that means from here to here is 6. So I'm going to put a little 6 here. So ignore this for right now and just make note that this right here is 6. That's my height. This is my other base, and it's 23. So for region 2, I have a height. So remember, this is a trapezoid, by the way, if you haven't noticed. So it's 1/2 the height, which is 6. B1, 23, plus B2, 15. Remember, the two bases. Now again, how you add those up or whatever, that's up to you. Plug that into a calculator, you get 114. And then, to find the area of this whole thing, you would say, okay, let's add up. So the area total, how about we put a little area total for T? That would be the 276, the area of region 1, plus 114, the area of region 2. And when you add those, you would get 390 centimeters squared. Again, because this is that. Okay? So I'll do a couple more problems, and then we'll move on to shaded figures. Alright, so since this is our first recording with this new format, I am going to go through every problem for these first two. These will be considered part of your notes. You're more than happy to fast forward me, pause me, rewind, and if you have questions, send them to me through Google Classroom or Reminder. Okay, so let's look at number 2. In number 2, you should see, depending on how you see this, what I see is 2 semicircles and a parallelogram. So I'm going to say here's my region 1, and again, I'm noticing that is a parallelogram. So I need base times height. Again, if you're not sure how to, or what are the areas for these, then what I would suggest is go back and use the formula sheet that you have. Geometry Formulas Reference. I'll post it up again for y'all, but here's a picture. So there's a picture, just that's to kind of help you. But let's go back and look at this. Okay, so right there, I am saying that you have this right here as one parallelogram. So the area of region 1 is just base times height. So in this case, 5 times 6, which is 30. I will get that little thing right there. Okay. Oh, I take it back. I messed up. Hold up 1 second. I am so not smart. Okay. 6 is the radius. All the way across is 12. So this is actually 5 times 12. I should have been paying attention. And that would be 60. Okay. Now, I do need the radius because this circle right here. So I'm going to say, but like this right here, region 2 and region 3, they're both semicircles. And I can actually join those together for one circle. So I'm actually going to say that I'm going to get rid of this and say this right here is region 2. And I would use pi times the 6 squared to get that one. So when I do that, I get 113.1. So then again, what would I need to do to find the whole area? Okay, so I've got this into 2 regions. So the total here in this case is just the 60 plus the 113.1. And that would give me 173.1 inches squared. And there you go. That's all you have to do on that one. Okay, so now let's look at the next one. Okay, I can see a rectangle, we'll say that's region 1. I can see a triangle, we'll say that's region 2. And then I can see a semicircle, that's region 3. So there I have 3 regions. And I think this is where things get a little bit harder because you're trying to realize what are all your measurements. Well, okay, so I'm going to find region 1, region 2, and region 3. Hopefully I gave myself enough space for all 3 of these. Okay, region 1 is obviously a rectangle, so it's just, I need to find, this is 9, I need to find this right here. Well, the nice part is, this is 9, so is the radius of the circle. So in region 3, I'm going to have 1/2 pi times 9 squared. That one I can easily get, because that's 9. That means then, 1 second. If that's 9, then it's also 9 this way. Okay, so let me erase this for a second here so y'all can see this. If this is 9, oops, helps if I switch here, then it's also 9 here, which means it's part of this right here. So if I subtract that, I would get 17. That would give me this part right here. Now I can say 9 times 17, that's region 1. Alright, well now how do I find this right here? That's a good question. Well, notice the 17 and the 7. That makes up this. So if I subtract, I get 10. And here's 9. So here's my triangle, 1/2, 9 times 10. That was my second region. So now I have everything I need to find all my different regions. And when I do that, the area of region 1 is 9 times 17, which should be 153, but I will double check. 153. Area of region 2 should be 90 and half of that, 45. And then the area of region 3 should be 127.24. And then again, the area of the total is just add up these 3. And so when you do that, you should get 325.24. Okay, so again, this is going to be longer than my usual because I want to make sure I go over everything I can. I may not do number 5, but I will do number 4. So let's get this one. Okay, so this one looks like it should be harder than it is. I'm sorry, it looks like it should be easier, but it's actually a little bit more difficult. Okay, so here's region 1, here's region 2. I can see in region 2 it is a triangle. The base is 16. Region 1 is a semicircle. The radius, now again, keep in mind that, I should put here region 1, 1/2 pi r squared. That's the radius, or that's how you find a semicircle. So that would be 8 squared. That one's easy. Okay, region 2, I'm going to do it like this way this time. I need 1/2 of base times height. the base is 16. But what's the height? Okay, that's where this gets a little difficult. So apparently, what you need to do here is you would have to do like, okay, realize that the radius, 8, and this right here, they make up a right triangle. Okay, so if I said 17 squared minus 8 squared, did the Pythagorean theorem in reverse, then that would give me 15. Okay, so that one would come out to that 17 squared minus 8 squared again gave you 15 when you took the square root, of course. Don't forget that you take the square root. And that would give you this height. That would be the height of this right triangle. And then once you do that, that's easy. So keep in mind that if you take the radius and the slant on a cone, an ice cream cone, because that's a common type problem, it can easily help you find the height of the triangle. So anyways, 16 times 15 divided by 2, and you get 120. So this one is 120. 0.5 times pi times 8 squared gives you 100.53. And then for the area of the total, again, all you got to do is add those two together, and you get 220.53 meters squared. Okay, so that's it for that. So now let's move on to shaded regions. Okay, so in this one, you're trying to find the area of the entire figure, then you subtract the area of the non-shaded regions. So like on this one, what I do here is I find like the area of the large figure and subtract out the one. So like it's still kind of the same thing, but we'll see how it would go. So let's start off with number 6. Okay, you've got a square. So if you find the area of a square, that would just be 25 squared, which is 625. Then you've got this area of a circle. Okay, now if the area of this, if the side of a square is 25, that also means that it goes 25 across this way. So if I cut that in half, that means the radius is 12.5. So here I have pi times 12.5 squared, which gives me 490.87. Excuse me. Okay, and then I need to subtract those two. So I need to subtract those two to get the shaded region area. I'm going to put here shaded region, or S for shaded region. Okay, so if I subtract 625 minus the 490.87, I get 134.13 feet squared, square feet, and there you go. Okay, so here, what do I see here? On number 7, I see a rectangle with a base of, let's say, 14 and a height of 25, which should give you an area of 350. Then I have a triangle. Boy, I'm very good. Half of the base, which in this case, the base here is this 25, times the height, which is 11. So they made that one pretty easy for you. So if you say 25 times 11 divided by 2, you get 137.5. And again, you need to subtract to find the shaded area. So if I say 350 minus 137.5, I get 212.5 centimeters squared, or square centimeters. All right. Okay, last 2 examples, and then I'll be done, and then you can finish out the other 2 pages on your own. But again, if you have questions, feel free to send me your questions. All right, so what do we see here? We have a shaded region that's a semicircle. So again, this would be, that semicircle is 1/2 pi times the radius squared. Now, how do you find the radius? Ooh, that's a good one. Okay, well, here's the thing. This has to be a 90-degree angle. Well, I'm kind of presuming that, to be honest. So if you And these are both your legs. So in this case, I could say, do the Pythagorean theorem, 9 squared plus 21.6 squared, and take the square root of that, obviously. I'll put a little square root. So if I said that 9 squared plus 21.6 squared, and take the square root, I get 23.4. Now that means this whole thing right here is 23.4, so I would need to divide that by 2, divided by 2 to get 11.7. So the radius here is 11.7. Okay, so if I use that and then square it, that will give me the area of the semicircle. Now the area of the triangle is this 1/2 of 9 times the height, 21.6. So there's that. And then you can go from there. So the answer that you should get for both of these, let's see here. 0.5 times pi times 11.7 gives me, whoops, forgot to square that. Well, let's go change that. 215 here, 0.03. And then 0.5, because 1/2 is 0.5, times 9 times 21.6, and you get 97.2. And subtract those two, 215.03 minus 97.2. I can't type. Alright, so the area of the shaded region here is 117.8. Oops, hold 1 second. 0.83 meters squared. And again, guys, I would give you some leeway in latitude. Alright, now comes the fun one. Oh no, what will I do? I have no idea. This becomes interesting. The last example here, how do I find this radius? Or how do I find that radius, because that semicircle? Because what I do have is a trapezoid. This right here is a trapezoid, which would be 1/2. Oh, I need the height of that trapezoid. So 1/2 the height times the basis, 17 plus 37, added together. Do you think there could be a reason why they gave you that 25? There is! Okay, so look. And this is where, again, you got to develop strategies. You got to look for other shapes. If I divide this right here, I now have a 90-degree right triangle. So what's the distance right here? Well, subtract 17 from 37, you get this to be 20. Now I can say, all right, I've got the hypotenuse, I've got a leg. If I say 25 squared minus 20 squared and take the square root, that will give me 15. If that's 15, that's the height of the trapezoid. Now, if I divide that by 2, then the semicircle radius, excuse me, will be 7.5. So that means 1/2 pi times 7.5 squared. Now, again, why would this matter? And I'll talk about something like this in a minute. But if I put those in together, okay, so what would I get? Okay, so I get this one to be 405, and I get this one to be 88.36. Leave myself enough space. And again, I would subtract those two, so 405 minus 88.36, and I get the total, or the shaded area here, is 316.64. So you get some ideas, and again, some of you are going, why do I need to study this? Let me give you some, like in construction, you may do some of these things, and I'm just giving you just an example that pops off of my head. Now, I know I have seen pools that have funky shapes. Like they're not all rectangular. Like maybe they have like something like this, but you have a deck that also goes around it. Well, think of that deck as like the shaded region that you're finding in the shaded region. And you've got a rectangle and a semicircle to deal with, you know? Or what about if it was kidney shaped? And how do you come up with those areas? And think of this. This is area, but the pool itself would be surface area. And then the water inside it would be volume. So you kind of see how we start developing this. And all of these would be very helpful for you. Anyways, I just wanted to give you that. Hopefully y'all are doing great with this. And if y'all do have any questions, and again, make sure send them to me through Remind or through Google Classroom. Don't forget you can do the Cami extension to finish out this assignment. You will do those last few pages, the 2 pages for this one, and we will go from there. Thank you so much for your time. Good luck. Be safe.